calculate the expected value, variance and standard deviation for the probability distribution shown here. Now it's the same one we used in the previous example. So we should recall the expectation of x is equal to 2. Remember, the symmetry of the distribution tells us that anyway. The variance of x turned out to be 0.5, and the standard deviation, of course, the square root of that is 0.707, correct to 3 decimal places. Now, consider the probability distribution of y. You can see that this is just 10x. We've just taken the distribution of x and multiplied it by 10 to get 10, 20, 30. So when it says write a relationship between x and y in the form y equals question mark x, we can say, well, y is 10x. We're now asked to calculate the expected value, variance, and standard deviation for y. Well, the expectation of y, again, using the symmetry, is just going to be 20. Now, the variance of y, we know we calculate by doing the expectation of y squared, take away the expectation of y squared. Now, I'm just going to pause recording while I calculate this. So you can see I've done the expectation of y squared here. So that's 10 squared times 0.25 plus 20 squared times 0.5 plus 30 squared times 0.25, which gives me 450. And then we take away the expectation of x, which was, or expectation of y, which was 20 squared, and that gives me 50. So the variance of y is 50. And then if I square root that last answer, it gives me 7.07. So SD of y is 7.07 if I just go to 2 decimal places here. Now, let's just quickly compare some values. The expectation of x is 2, expectation of y is 20. Variance of x is 0.5, variance of y is 50. Standard deviation of x is 0.707. Standard deviation of y is 7.07. So write a relationship between the expectation and the expectation of y in this form. The expectation of y is 10 times the expectation of x. Now, if we think about the relationship between variance of x and variance of y, remember the variance of x was 0.5 and the variance of y is 50. That means that the variance of y is 100 times the variance of x. And then write a relationship between SDX and SDY. So SDY, now the standard deviation for x was 0.707. The standard deviation for y was 7.07. So that's 10 times the standard deviation of x. So what do we notice? Well, we noticed that the expectation of y was 10 times the expectation of x. The variance of y is 100 times, or 10 squared times, the variance of x. And the standard deviation of y was 10 times the standard deviation of x. So multiplying by 10 affected the expectation, it affected the variance, and it affected the standard deviation. So both location and spread. And the only time that it wouldn't affect the location is if we had a situation where the expectation of x was 0, because then, of course, 10 times 0 is still 0.